An introduction. Welcome to the UAE STEM Pro, an educational STEM program for young researchers focused on building strong partnerships between universities and industry in Ukraine. UAE STEM Pro is an initiative of the Ukrainian President's Fund for Support, President's Fund for Education, Science and Sports, delivered in partnership with the University of Warwick with the support of the UK-Ukraine Academic Diaspora Network and the UK Foreign Commonwealth Development Office. It's a great pleasure to welcome our speaker today, Professor David Greenwood, the Director for Industrial Engagement and CEO of the High Value Manufacturing Catapult at WMG, University of Warwick. His work sits at the intersection of academic excellence and real-world industrial impact. So we're delighted to have you here with us, and over to you, Professor Greenwood.
Thank you very much, and good afternoon, good evening, everybody. Thank you very much for inviting me this evening. I think the topic that we're talking about essentially has been the focus of my career. And so I hope that I can help a little. Just to give a little bit of background, I started my career in industry, and I worked for 24 years in engineering and engineering consultancy, working with a company called Ricardo, developing advanced technologies for vehicles. So some of that was passenger cars, race cars, military vehicles, all kinds of fun things. And I transferred from industry, where I was writing strategy for government to invest in research and development, and where I was helping companies to invest in research and development. I moved over into the academic sector in 2014, where I've now been working with researchers to help them understand how to get their research deployed fully in industry. So I'd say I'm 2/3 industry and 1/3 academic, if you were to kind of work out where I was coming from. And my role here is as the chief executive of something called a Catapult Centre. I'll explain what that means later, but essentially it's the UK's main funding mechanism to try and draw academic knowledge into industry at scale. So I've got probably about 15-20 minutes worth of presentation material just to explain what we do, how we work, and then really there'll be loads of time for question and answers after that, and that's probably the bit where we can structure the conversation more helpfully around the things that are of interest to you. So if you'll just bear with my awful Zoom skills for one moment, I will just bring up the presentation slides. So one second. So I'm hopeful that you can see the slides there. Could somebody confirm that for me?
Yes, we can see.
Wonderful. Okay. So thank you very much. So this talk actually follows on from one that took place a week or two ago with my colleague, Dear Ardash. I would say if you haven't seen that talk, I believe that was also recorded, and it might be worth going back there just to get a little bit of the context, which I won't repeat today. But really just to say, by way of context, the organisation that I work with, WMG, or Warwick Manufacturing Group, is part of the University of Warwick. And you'll have seen we are typically viewed as a top 10 UK university, top 100 global university, and we're part of the UK Russell Group, which is the group of research-intensive universities. But for me, running the WMG and the Catapult Centre at WMG, what that means is I sit in the context of a full function university, which means I can reach out into language departments, chemistry departments, physics departments, maths departments, any of those resources that I need in order to be able to take the research that we do and to embed it firmly in industry. Because the department that I work for, Warwick Manufacturing Group, was started in 1980 by Professor Lord Bhattacharya, whose picture you can see here. And he, at the time, looked around the situation in the middle of the UK, in the Midlands. This was the heart of our UK car manufacturing industry. And in 1980, the UK car industry was known for a few things, and none of them were good. That we had enormous problems with quality of products in brands like Austin, Rover, and British Leyland. We had some awful labour disputes between management and staff, and the industry just wasn't profitable. It ended up being nationalised in plenty of places. And Lord Bhattacharya looked at the best practice that he could see elsewhere around the world, and also coming from academia. And he founded our group predominantly to bring both leadership and management skills and technical skills into the industry in this region in order to transform it. And that really has been our mission over the last 45 years. The industries that we work with have expanded, the technologies we work on have expanded, but our core purpose, which is about delivering innovation into industry, has remained constant throughout that. And we deliver that by having quite an unusual staffing model as much as anything else. So rather than a traditional university department, half of the staff who work here, and there's just under 1,000 people in my group, about half of them come from industry, like me, and about half of them come from academia, from more traditional academic careers. And that means that we've got the ability to build teams where we've got the very best of foundational academic knowledge coming together with groups of people who know what the needs of industry are and how to deliver to industrial timescales and what combination of deliverables will be viewed as success by industry. That's quite an unusual structure for a university department. And we say that our purpose is to deliver the technology, the knowledge, and the people needed by the industries of today and the future. And that comes through a couple of different routes. So the technologies and the knowledge come from the research work that we do, and that's about half of our total portfolio. And the knowledge and the people comes from the educational part of what we do. So that's teaching people through different parts of their career. So roughly half of our business is on educating people and half of our business is in doing research. But in combination, they're aimed to deliver these three key things: technology, knowledge, and people, in a form that industry can absorb it. Our research is across 5 key themes. I'm not going to go into a lot of detail of them here, because actually the specific technologies we work on are not terribly important to the way that we work with industry. And what I would say is that that mission I described a moment ago, that 45-year mission to bring technology to industry, whilst that mission has remained constant, if I'd put a slide like this up every 5 years, the technology areas that we're focusing on, or even the industry sectors that we're focusing on, probably would have changed each time. If evolution rather than revolution, so we'd have probably added a few and deleted a few each time. But if you look at the kind of things that we're working on, you can see that predisposes us to working on industries like automotive, aerospace, power generation. We do a lot of work on things like batteries, and we're starting to move more towards work in the defense arena as well. But as well as being a university department, we are something called a Catapult Centre. Now, the Catapults are a mechanism that was set up by the UK government in order to fund the translation of knowledge from universities into industry. And there are 6 of these centres up and down the UK, and we all deliver 2 things. One thing that we deliver is technical specialism. So in this particular case, the University of Warwick has a technical specialism around battery and battery technology, around electric motors and electric machines, and around steel and the steel industry. Whereas other centres like NCC, the National Composites Centre, as the name suggests, focuses on composites. CPI, the Centre for Process Industry, focuses on chemical process engineering. So each of the centres has a unique speciality function, but we also have a regional delivery function where, for things like robotics and automation and digitalization, which are needed across the country, we have a regional delivery capability to reach out into companies local to us. And this mechanism gives us access to around 20 to 30 million pounds a year of funding that we can use to co-invest with industry in order to take technology forward. And I'll say a little bit more later on about how we use that money. And I describe our delivery model as being like a flywheel. There are a couple of key elements to it. And it's a triumph of evolution over design, because our positioning in the industry and with government starts from a position of thought leadership. And that thought leadership has been developed through the research that we conduct. The research that we conduct allows us to work with industry. And in working with industry, we deploy the research that we've done, but we also learn about what the next generation of problems is going to be that we should be directing our work towards. And that working with industry also allows us to define what kind of education and skills offer we need to be able to make in order to train the people that are coming through the industry in the next decade. That in turn allows us to work with government and to support government in creating policy and writing policy. And that engagement in writing policy informs our thought leadership. So you can see there's this virtuous circle here that for the industries that we work in, we work with across that triple helix of government, academia, and industry, and delivering research and education. And that puts us into this increasing position of knowledge and trust and thought leadership that grows our reputation in the particular fields that we focus on. And in that working with government part, because we work closely with industry, government is happy to talk to us to understand an unbiased view of what industry needs. We are actually a charity. We're not a profit-making organization. So when we give advice to government, it's not because we're going to make money out of it. It's because we want the right things to happen. So, for instance, when the UK government decided that it wanted to create a battery industry in the UK in order to secure its automotive sector and its aerospace sector and serve other sectors as well, they were able to work with us to understand what kind of interventions they would have to make to allow that to happen. And what we explained to them was that you need to create an ecosystem where you've got fundamental research at one end, but it's not blue sky fundamental research. It is fundamental research which is guided by the questions or the problem statements from industry, so that you get the best academics in the country working together on large programs which will really remove the key pain points that industry feels both now and in the future. Once you've developed that fundamental research, we then encourage them to put mechanisms in place where industry can start to engage with that. And that's when you get to this kind of technology readiness level 3 to 5, where the typical mechanism that we use in the UK is collaborative research and development funding. So there, the government will make available money for industry to bid into, and industry has to come forward with 2 or 3 or 4 companies all working together in order to create new products or new services and to build a business case for that. And if that business case is strong enough, then the government will put in part of the cost of delivering the project. So typically about half of the total cost will come from government. The other half is borne by industry, and that funding de-risks these investments for industry. It allows them to participate in riskier technology developments than they would otherwise do. Once they've got through that process and they've developed the concept, so developed their first prototype, for instance, there are then mechanisms that are put in place which allow the companies to work out how they're going to go from that first prototype through to full-scale manufacture. And indeed, those programs are big enough that they can contribute significantly to the cost of productionization of a product. So there we've got programs that run under the Advanced Propulsion Centre and the Aerospace Technology Institute. So they are a couple of government funding bodies where again, companies can bid in for up to 50% of the money to build facilities to be able to manufacture product. And that can be funding up to about £50 million per product. So it's quite significant. And then on the far right-hand side there, we've got the really high technology readiness level interventions. So this is really where we're looking to get companies manufacturing at large scale. And there are several mechanisms available, some of which are non-financial, like helping the Department for Business and Trade to find land for factories to be built on, to help with the planning permissions, to put power in place, help generate the skills, those kinds of things. And some of them are financial interventions. So with the Automotive Transformation Fund, we've got about £1 billion worth of funding that we can use to co-invest with companies building large-scale factories here in the UK. And what we were able to do as Warwick Manufacturing Group, because we work with academia, because we work with industry, because we work with government, we were able to see the big picture and explain what sort of mechanism you would have to build in order to allow this seamless transition through the infrastructure. And actually, we helped to write this entire funding mechanism for government. That was then adopted by government, and so far they've put about £1 billion of R&D support and a further £1 billion of manufacturing development support in place to help companies to enter that industry. And some of what we had to do was to deliver the critical infrastructure that companies needed in order to be able to prove out their concept. So for instance, when you're making a battery cell, you can only really prove that you can manufacture it at full-scale production rate. So 20 cells a minute is a fairly typical production rate for these kinds of facilities. The only way you can prove that is to have access to a production facility, but those facilities cost upwards of £100 million. So it's beyond the means of most individual organisations to invest in that. And we were able to build a business case to government to say, why don't we build an open access version of one of those factories, which any company can come into, they can develop their technology, they prove it works, and they leave with all of the intellectual property that they need in order to make their company succeed. And we were successful in securing that funding. The pictures that you see on the screen here is the UK Battery Industrialisation Centre, which we built in order to provide companies with access to do that kind of thing. And that's been running now since actually it came into full operation in 2019. So that's been running for nearly 6 years now, and we're actually doing the process of doing some upgrades to it at the moment. So the sectors that we work across, given the nature of our activity, do tend to focus around automotive, and that's because where we are based is the home of the automotive industry in the UK. So just under half of our work is in automotive. We then have a fairly strong piece of activity around other forms of transport. So aerospace is about 12%, and other transport, so that's rail and micromobility and things, is another 12%. And then rail takes us another 6% beyond that. And then we have some adjacent sectors, so things like sustainable materials, so for instance, things like steel and composites. And we've got some increasing activity now in things like agricultural technology and food and drink. But ultimately, these have come from a technology portfolio that was originally developed for automotive, and then we've discovered that it's got applications in other areas. So I think if you look at the shape of our portfolio, it's likely to remain quite similar to this. We want to be working across multiple industries because all of these industries have peaks and troughs in their profitability. And so that means that you've got to work with multiple partners. Otherwise, if one of them goes quiet on you for 3 years or 4 years, then suddenly your business is under threat. So by working in counter-cyclical industries, we're able to balance that risk and also to take learning from one industry sector and introduce it to another. So as a result of that, I've just put a small proportion of our partners on the screen here, but we've got about 1,000 industrial partners that we work with on a regular basis. Some of them are really big, companies like Ford or JCB or Cummins or Aston Martin, and some of them are really small, little startups that are coming out with new technologies and need to work out what their path to market is going to be. And some of these relations are tactical. There's a single piece of work a company needs to do with us in order to do what they want. And then once they've got what they want, they'll leave and do their own thing. And some of them are really long-term collaborations that have been running for decades, where we've got complete transparency with our industry partners. We understand exactly what their future technology roadmaps look like, what their future product needs look like, what their technology needs look like. And that means that we can be investing in advance of their requirements. So by the time they know they've got a problem to solve, we've already built the knowledge and facilities that are needed to be able to answer that question. So the way that we deliver to industry, well, there are 6 different business models, if you like, that we use to deliver to industry. The first of those is capability development. Now, what that means is this is us taking money from government in order to develop technical capabilities ahead of industrial demand. And that's typically taking the results of the research work that's coming from our academics and looking to develop that to the point that industry could start to work with it if they were interested. Once we've done that, we then set up strategic industrial partnerships. So those are then typically co-funded activities between us and industry partners, where we take those capabilities and we start to deploy them in industry for the first time. And there's some risk sharing in that, which means that the government pays the industry for part of their engagement and the government pays for all of our engagement. But the industry partners at the end of it do have the rights to use the intellectual property that comes from those programs, and that's really important to them. The next level up from that is the collaborative research and development mechanisms that I talked about earlier on. And that's where we bring not just one company in to work with us, but multiple. So we might bring a car company, their tier 1 supplier, and 2 of their tier 2 and tier 3 suppliers to develop a product, demonstrate that it works, demonstrate that it's manufacturable, demonstrate that it meets the end goals, and do that all directly with the vehicle manufacturer. And all of those partners are sharing in the risk of that program, but as a result of it, all of them will then gain from the supply chain opportunity on the outcome, as long as it all works successfully. Alongside that, we have programs where we help to upskill companies, because we recognize there's no point in doing innovation if the company that you're working with doesn't have the skills to be able to embed it. So we have multiple programs where we will help to upskill the employees of companies, sometimes short courses, a week long, sometimes master's degrees or engineering doctorates or PhDs, 4 years long. But all then aimed at making sure that industry has the absorptive capacity for the innovation that we are delivering. And we recognize that when you're working with small companies, you have to work very differently to when you're working with large companies. Large companies typically have whole teams of people who are trained up to understand how to work with universities and how to access government funding and how to implement innovation inside their organization. Small companies typically don't have that capability. So I have a dedicated team here whose job it is to identify small companies who we think that we are in a good position to assist, to really work one-to-one with them and understand how to take our technology into their workplaces in a way that works for them in a small company environment. That means typically it can't be expensive, it's got to move very quickly, and it's got to be easy for them to absorb into their organization. And then the last of the sort of 6 mechanisms that we use for working with industry is what we call direct contract research. It's a bit like consultancy. And the key thing here is this is a commercial relationship directly between us and the company, where they believe that we've got the ability to solve a problem for them. We can give them a quotation to do that work. We deliver the research, and at the end of that project, all of the intellectual property goes to the customer. If they want it to be completely confidential, if they don't ever want anyone to know that we did the work with them, that's absolutely fine. We don't need to publish. Everything can be done behind closed doors if necessary. But in order to get that, the industrial partner is paying a premium. So the rates that we charge for that kind of direct contract research are much higher than the rates that we charge for things like collaborative research and development, for instance. And so just to give a little bit of an example to that, in the UK, not far from here, we have a company called Triumph that makes motorcycles. And I had a conversation with them a few years ago to say, look, if you look at the way that cars are going, they're all going electric in the UK and Europe by about 2030 or 2035. It probably isn't going to be long behind that motorcycles are asked to do the same thing. Are you ready to do that? And Triumph came back at that time and said, no, they hadn't ever built a high voltage battery before. They'd never built an electric motorcycle before, and they really wanted to learn how to do that. So in the first part, we worked with Triumph to help them understand how making an electric motorcycle could give a quality of motorcycle that suited the Triumph brand. How could we make an electric motorcycle more of a Triumph than an internal combustion engine motorcycle? And we helped them zoom in on the particular set of performance criteria and range criteria that would really make an outstanding product for Triumph. And the motorcycle that you see in the picture here is the result of that project. But to get to that, we also helped Triumph to understand who were the likely supply chain partners that they would need to work with, so that when we finished the project, they would be able to buy all of the parts that they need and put this into production. So although Warwick Manufacturing Group could have developed every component on the bike for them if they'd needed us to, it was more valuable to the company, to Triumph, to have some suppliers on board who could provide those components to them in production, because that's not something that we as a research institute would do. And so we helped them identify, at the time, Integral eDrive and Williams Advanced Engineering, who developed the battery and the motor respectively. And WMG played a part in the overall product specification and all of the control strategies that went into that. So this motorcycle produced a proof of concept, which was track ready and went into testing very successfully. There was a lot of learning for Triumph in that. Now, interestingly, one of the pieces of learning was that this was not actually the exact motorcycle that they needed to make in order to hit the market. And unfortunately, I can't go into a lot of detail about where they're going from here. Then they're not going to take this particular motorcycle to production, but they do have some other electric motorcycles in their development portfolio at the moment, which are in slightly different product areas, which take a lot of the learning from this program and apply it in different ways. I talked about working with small companies. So, working with large companies like Triumph, they already have ecosystems in place to work with universities, and they're quite good at adapting to adapting the results of research. When small businesses, that just isn't the case. So our small business team is particularly skilled at taking the language of academia and turning it into the language of small here and now businesses, and working out what type of technology will fit their businesses now and which ones are ones that will deliver in the longer term future. Generally speaking, we don't tend to work with small companies on technologies that are more than 2 years away from production. There are some exceptions, but generally speaking, these companies have got a very fast heartbeat. They need to be able to absorb technology immediately and turn it around immediately. So we have specific programs on particular interventions, whether it is how we can help them become more digital in their manufacturing, how we could help them with sustainability, how we could help their supply chains, how we could help their business growth, and in some cases, how we can develop their leadership to be more capable of innovation inside the organization. So the way in which we offer industry to engage varies depending on what they're looking for us. At the early end, we can work on scientific grants. So that's your more typical university research grants. And there, the role of industry is really just to set the direction and tell us what the interesting problems are. We don't expect a lot of engagement from them. We don't expect a lot of money from them. Really, we're just looking for them to guide the direction and to benefit from the knowledge that comes from those programs. But as the technical and scientific risk comes down, then we move into those collaborative research and development mechanisms where we bring multiple companies together to de-risk technologies and products and demonstrate their readiness for market. And as the technology becomes even more mature, we work through that direct contract research mechanism, so that commercial research mechanism, to really embed the intellectual property inside the company and help them take that through to production. And alongside that, we run some of our skills offerings, so things like engineering doctorates and master's programs, in order to help the company build their knowledge and skills to be able to absorb and deliver that research into the future. And then in the short term, we've got some skills programs that are aimed to really provide quite short interventions, sometimes just a week long, to help companies improve their knowledge or skills in areas that are new to them. And if you ask me really, what are the critical success factors for us in working with industry? The first thing I would say is that it's absolutely critical that we don't just have scientists and researchers working in those programs. The fact that we're able to bring experienced industrial engineers into the programs working side by side with the scientists means that we can get the right balance between scientific rigor and also scale of ambition with industrial timescales and industrial needs. It's about understanding how far you can push, how far industry is prepared to travel with you in terms of risk, and how much of the implementation they need to be able to see tomorrow and how much in 3 years or 5 years. The second thing is that in order to do that, we have to invest here on our site in the kinds of facilities that will deliver against industrial scale and industrial pace. So I showed you the UK Battery Industrialisation Centre. That was a £130 million investment. So really quite significant investment. And if you look at the assets on our campus at the moment, it's not unusual for us to be working with full-scale industrial equipment, pieces of equipment that cost 8, 10, 15 million pounds each. But we have to do that in order to be able to help industry de-risk the technology to the point that they're happy to embed it within their own business. I'd say the third critical success factor is we as WMG don't get too stressed about owning intellectual property. I think one of the next talks you've got is from my colleague Tim Hart, who will talk about the university's intellectual property strategy. For me, I would rather place the intellectual property from our research into the hands of industry, because they are far better resourced and equipped to take it to market and really deliver impact at scale. And generally speaking, universities are pretty poor at owning and managing intellectual property. So unfortunately, we see lots of brilliant IP stuck in universities and never really making its way through to industry. So our model is to give away the IP wherever we can, or at least make it openly available to industry in the knowledge that they will then push it hard and take it to industry. I talked earlier about the fact that we have this triple helix model where we are a trusted partner to industry and to government. And that's a critical success factor in both directions. Industry likes to work with us because they know that we understand the direction government is taking in the future. And government likes to work with us because they know they can get an unbiased opinion on what is realistically possible within industry and not. And having that three-way relationship, academia, industry, government, is really a critical part of our business model. But finally, I would say that the real critical success factor is around a culture of innovation and impact. And if you want to know what that means for real, in the days when Lord Bhattacharya was running the organization and I reported to him, I had my annual performance review once a year. It lasted 15 minutes and there was only one question. And the question was, Dave, how did you change the world this year? And looking at your shoes was not an option. He judged the success or failure of me and the organization as to whether we had changed the outside world, not whether we had met internal metrics. And I think in working with industry, that is one of the most important things to keep a focus on. So I hope that's enough to give a little bit of a sort of positioning as to who we are, what we do, how we work with industry today. And I hope that gives a good basis for us to have a bit of a Q&A and a bit of discussion around that. And if I can work out how to take the slides down, there we go. Then hopefully I can see. So I'll hand back to Ileana to chair us through, if that's okay.
Yeah, sure. Thank you so much, David, for the presentation. I mean, I have questions myself, but I will over first to the participants and then I'll ask my questions. So Andrei, please go first.
Yeah, good evening, Dave. Thank you for your presentation. And my question is about collaboration between the center, because you said that you have 6 centers, and I'm interested in how they collaborate, if they have some projects that overlap different disciplines, and how you could you at least acquire specialists from different centers if such project exists.
So if I'm perfectly honest, when those 6 centres were first set up, they did not collaborate very well together. Their individual missions to begin with were really all about getting themselves established. And if I'm perfectly honest, we did have some problems at one point in time when the centres were even competing against each other. What I would say is that's definitely no longer the case. About 5 or 6 years ago, we did a really big piece of work looking at understanding to what extent the activities in the centres were collaborative or complementary, and to what extent they were competitive. And actually now we have a situation where the CEOs of those 6 centres meet every week to work out how our businesses operate and to work out where we should collaborate. And I would say where we are now, there is a very, very strong level of collaboration. And that's been possible because we've been able to much more clearly define what our individual expertise is. And we've been able to hold each other to account as our businesses develop to make sure that we don't develop too much overlap to the point that we become competitive. A little bit of overlap is good because that means that if I have a company I'm working with that I need to pass into one of the other centres, I can take them far enough that the other centre is ready to engage with them. But we don't allow too much overlap that would place the centres in competition. So right now we do genuinely operate as a very strongly linked network of 6 centres. And in fact, we've created a 7th body which looks across the 6 centres, and it was created by the 6 of us, and we created that 7th body to hold us to account collectively.
Thank you. Thank you.
Thank you. Ivan, please go next.
Yep. Thank you. So in your presentation, you mentioned that automotive actually takes the most part. And my question is about, could you name main challenges actually in this area as for now?
So right now, automotive is struggling with a few things. I would say one of the biggest challenges it has right now is the fact that the technology is moving from internal combustion towards electric. And that requires a huge change in manufacturing techniques and skills and process and supply chain. So that's been a really big challenge. And we've been spending a lot of time helping to develop the component technologies that they need and help them understand how to integrate that. Alongside that, there have been enormous challenges for the automotive industry in security of supply chains. The global geopolitics means that at various different times, entire sections of supply chains have become unavailable. We've had semiconductor crises. I clearly don't need to explain to you what's happening in the Ukraine at the moment, but Ukraine was a fantastic producer of wiring harnesses, for instance, that went into the automotive sector. And unfortunately, what's happening at the moment has meant that the automotive sectors had to look at different ways of achieving that kind of sourcing. And then the third thing that the automotive sector is looking to do is to become more sustainable in the long term and think about how its products can become more recyclable and more circular. And those are probably the kind of biggest drivers on the automotive research portfolio at the moment.
Okay, thanks.
Victoria, please go next.
Thank you very much for your speech. It was truly valuable for me. And frankly speaking, if we had more time and opportunities for an extended discussion, it would be a pleasure. But unfortunately, we have limits and have to follow the schedule. However, with your kind permission, can I ask two questions? So the first one, you have already mentioned that at the WM group, you have representatives from academia and from the industry. So it's obvious that the academic staff gained some industry experience. So in your view, what formats of industry placements or secondments work best for academic staff, like short-term immersions or part-time engagement or longer internships, so to gain the industry experience? The first question. And the second one, how can universities, especially with limited resources, motivate companies to invest time and resources in the hosting academic staff for internships or some applied projects?
Yeah, so those two are very related. And in fact, I'll start on the second one to then sort of link to the first one. So I'd say that the first thing is that when dealing with industry, the first question to ask yourself is what's in it for them?
Mm-hmm.
Why should they care about what you're doing?
Okay.
So to a certain extent, you can look at the shape of an industry and think about what the challenges are that it faces. And many industries already publish things like technology roadmaps, or they will have trade bodies that will talk about the state of their industry. And you'll be able to pick up from those, what are their real challenges today? And then what you've got to think about is your research the right answer to that challenge? Or where is your research the right answer to that challenge? Because if the honest answer is your research is not helping them with that challenge, then go and find a different industry partner for whom it is, because you'll never succeed in getting them interested if it's not a problem for them. It really is as simple as that. But then once you have looked at that challenge, think about what they care about and how you're going to position your research. So for example, when I'm talking to our researchers here, I wouldn't suggest that they go into a company and say, I've developed this fantastic new composite material. It's 5 times stronger and 3 times and a half the weight of anything that anyone's done before. I would encourage them to think about, what does that mean for the car maker? What that means is what my technology will make your vehicle more fuel efficient, which means more people will buy your car.
Okay.
So you need to think that through. So how you motivate them is talk to them in the language they understand. They think about the next generation of product. They think about whether they can do it profitably. They think about whether it can fit into their system. If you come up with something that is brilliant but unaffordable, regrettably, that's no use to them. They need to be able to work out how it comes. So the first thing is place yourself in their shoes. And when you talk to them about the benefits it will deliver for them. They will ask you a bunch of questions, which will then allow you to explain what your research is and how it fits. But you've got to get their attention in the first place. And what that means in terms of your first question, which is what type of engagement is the most valuable, I would say by far the most valuable, if you can achieve it, are the long-term engagements, because what they do is they let you understand the culture of the organization and what truly motivates it. And that means that when you then do go back to say, look, my research could be really interesting to you, you know from the inside what makes them tick. You know that you're going to position it correctly in their terms. So if you can't get those long-term engagements, then clearly short-term is better than nothing. But the very best thing is to be working with them on a project over a period of a year or more to really understand how they think. I think we may have an issue with the Wi-Fi. I'm not sure whether that's at my end or the other end.
No, we're all here. Yeah.
Excellent.
Perfect. Thank you so much. Have you covered the two questions, right? So, because I think
yes.
I missed some part. Perfect. Thank you so much. So, Mihailo, please go next.
I had bad internet connection, but I have in speed I have listened to the answer. Thank you very much.
But my contact details, by the way, are on the presentation material, which has been recorded. So if anyone does want to contact me after the call, then you're always very welcome to drop me an email.
Thank you so much. Mihailo, please go next. Mihailo, we see your hand, but we probably, I don't know whether you can be the next one. Yeah? No? If not, then Roman, please go next.
Hi, dear David. I have some question. You mentioned about the IP. It's quite interesting sphere to our universities, and you mentioned also that you try to sell the IP as soon as possible. So what is the best strategy about the IP? I mean, in terms on how to generate the revenue, is it better to sell the IP, or to try to convert this IP to some equity, for example, some part in spin-off company, and then to sell this equity? Which is the best on your mind?
So to the greatest extent possible, I look to, I judge success by whether the intellectual property that we develop ends up in the marketplace at scale. And so for me, it's actually not about making money from the IP. I make money when the company that we work with comes back to us and engages in another large research project. So actually, to me, the IP is a benefit that I am comfortable for the company to retain as far as possible. And in many cases, we don't actually ask for money for it because they've already paid for it in the research project that led to its being created. Now, there are some exceptions to that, and that's where there are not companies around that would be the right vessel to put the intellectual property into in order to have it exploited. And there, I think, either having spin-out companies or joint ventures is entirely valid. But for me, I don't really focus on revenue generation from IP as being an important business model. It's really hard. In perfect honesty, it's very difficult to get IP agreements and be profitable from an IP investment. Generally speaking, for me as a researcher and for me as a research organization, it's much more valuable that the company comes back and sponsors another 3 years of research in the knowledge that they will take the benefit from the IP that comes from it.
Okay, thank you very much.
Now, I would say if you were going to go down the model of revenue generation, then the honest answer is it's really complex. Different sectors deal in different ways. Some sectors will pay a fortune to avoid licensing something because they're terrified of being held to ransom by a single supplier, and that's the only place they can get something. Some sectors will license very readily. So things like pharmaceuticals and life sciences, they tend to be very receptive to licensing or acquisition of IP. Industries like automotive and aerospace, it's really difficult, honestly, to get them to make a significant investment in IP.
And who is the IP owner during your collaborative R&D projects?
So very often we might be the generator of the IP and we will be recognized on the patent, but very often we will assign the IP to the industrial partner so that they can take the product to market.
Okay, thank you.
Thank you so much. Mihailo, you wrote that you have issues with
hello.
the microphone.
It's great that I can be heard. And thank you for your great presentation. It was very informative, and indeed you described a lot of ways in which you are helping in collaboration between industry and academia. And most of that ways, as you described, requires some kind of government support, either investments or organizational. And my question is, can anything like that be done without an active support, and to what degree?
So the role of government support in these things is to allow for a greater level of technical risk taking. So it is entirely possible to do research and development with companies which is completely commercially funded. But the reality is that they will be looking for relatively fast implementation into their business, and they will typically be a little bit more, well, actually quite a lot more conservative about how much technical risk they're prepared to accept. When government invests alongside industry, it means industry becomes more willing to take a risk. They will be happier to invest with you at an earlier stage of the technology development. And as a result of that, you're able to do things that bring a more research content into the research. So I would say it's really difficult to get fully commercially funded fundamental research. Only a few very large companies, or in some cases philanthropic donors, really have the ability to fund fundamental research. Companies normally, if they're fully funding, would rather be at the applied research end of the spectrum.
Thank you very much.
Thank you. Olha?
Thank you for your presentation. And I was wondering if you could provide some insight, because in my experience, most manufacturers either can't formulate their problems or they don't have experience for collaboration with researchers and educational institutions. So I was wondering how to build this cooperation at the earliest stages. So how do we approach them, and how do we convince them that we can help them, or we can even help them understand what their main problems are?
It is tricky. I would say the first thing is to think about who in the organization are you talking to. So within a manufacturing organization, you'll have some parts of the organization that are absolutely laser focused on today's problems. And frankly, research and development is an inconvenience to them because it makes them change things. And changing things in manufacturing is the very last thing you want to do. So the people you don't want to be talking to typically are the procurement managers or the people who are responsible for day-to-day plant management. They might be interested in some things that could increase operational efficiency or help them to measure accuracy in production. But to be honest, they're not going to be the people who are the most predisposed to engaging with innovation. The kinds of people that you're looking for in the organization would be the chief technology officer, or maybe even the chief executive officer, because they're the people who tend to be looking at the company with a much longer time horizon, and they're the people who are thinking about what their competitors are likely to be doing. So they're the ones who have got the most incentive to do something differently and to take a bit of risk in order to get some reward. Now, unfortunately, if those companies have never worked with researchers before, then you've got a pretty long battle, but it is one worth engaging with. And the thing that you've got to do is just build trust that you have their interests in mind. I know, because I used to work in industry, there were loads of times that I was contacted by academics to say that I should be interested in their research. But in honesty, all they wanted from me was a letter of support that they could attach to their grant application in order that they would win the money. And as soon as they won the money, I'd never hear from them ever again. And all they really wanted to do was hide in the laboratory and do some interesting stuff. That's no value to me as an industrial person. So it's about building their confidence that what you're looking to do is to listen to their problem statements and solve their problems, and just give them a few evidence points along the way. Even if you've never done the whole problem before, at least give them some evidence points on where you've been able to take bits of your research and deploy them with industry. Now, clearly, if you haven't done that before, then the best thing is to work with some colleagues or find some people who have, and use that as the means of building that confidence that your institution is capable of delivering value to industry. But yeah, I'd say definitely, first of all, make sure you're talking to the right person, because there are antibodies to innovation in companies, and most of them live in the manufacturing end of the organization. Manufacturing is all about doing everything to quality, which means exactly the same to exactly the right tolerances 20 times a minute. Somebody coming in with a bright new idea and saying, hey, let's twiddle that, is generally not welcome.
Yeah, I know what you're talking about, because that's exactly who we usually talk to.
Yeah,
Thank
so
you.
talk to the chief executive, or the best person, if you can get to them, is the chief technology officer, because that's normally the person in the organization that's got the broadest technology view, and their job is to explain to the company what they need to become in the future.
Thank you.
Thank you. Lilian, please go ahead.
Thank you so much, Professor Greenwood, and for such interesting presentation and for sharing your valuable experience. Maybe my question will be close to Olga's question. And what would you recommend to early career researchers working as the interface of material science, energy systems, and industry collaboration?
So material science and it was energy systems, the interface of material science and energy systems. Yeah, that's first thing is that's a really great place to be. That is one of the hottest topics in industry at the moment. So the first thing is you're in an area where there is a strong level of interest. I would come back to have a think through. You need to have had some thoughts around where the likely applications are and where the fundamental benefits. So if you're working on the materials or the material science, start from thinking about what the fundamental strengths of the materials that you're working on are. What's the particular set of parameters that it offers that are not available today? So for instance, you might be working on a material that's extremely lightweight and it's extremely resilient, but it's extremely expensive. That tells you that the sort of customers that would be interested in it are not going to be people who are selling large volumes of low-cost products. It tells you that you should probably be going to talk to people who are in, I don't know, Formula One racing or high-end vehicles or defense products. So it helps you immediately make sure that you're talking to the right person. Most researchers fail to engage with industry because they take a beautiful solution to the wrong person. If you take a beautiful solution to the right person, you've got a better chance to succeed. I'd say in energy materials, if you look at what's happening, particularly around renewables, so batteries, power electronics, electric motors, wind turbine generators, small modular nuclear reactors, there's loads of new technology coming through. Sorry, say again?
Renewable energy sources.
Yes, so there is this huge explosion there of technology and a huge need for innovation. So I do think you're in a brilliant place, but I would start from just make sure that you've understood who is going to value the thing that you're working on. And then when you go to meet with them, make sure you explain it to them in terms that they will understand. So why do you think this is the right solution for their particular problem? And be careful not to overstate where you are in the process. The other challenge that I tended to face when I was in industry is an academic who had written their first paper on the topic. They'd got their first set of results and they were convinced that I should now be prepared to put £50 million into commercializing it before they'd demonstrated that it worked at the kilogram scale or the ton scale, or that it could be manufactured, or that it didn't degrade over time, or that it wasn't poisonous. All of those things you need to think through the questions the company will need to face between where you are today and the future. You don't have to have answered all of those questions. You just need to be honest about where you are in the process so they know where they're taking risk and where they're not.
Thank you so much. Thank you.
Thank you. Ilona?
Yes, thank you a lot, dear professor, for your presentation. It was so informative and interesting. And I have one question. As your opinion, in the next 10 years, which sphere is more perspective, between cooperation, for cooperation between researchers and industry in the world, and maybe your opinion in Ukraine?
Oh gosh, that's a very big question. I think, you know, I would go back to start with the United Nations sustainability goals. I think if you want a 10-year view on where is the world going to need to make its biggest research investments, those United Nations sustainability goals are a really good place to start. And it's about food security, it's about energy security, it's about environment, it's about preserving the environment, it's around circular and sustainable. But you've just got to remember that underneath all of those, it also has to be commercially viable. And that's a really critical part. Research only makes it to market if it is commercially viable. Somebody has to make money out of it for it to succeed in the marketplace. So I think that's the best advice I could give. But that's incredibly broad. You know, that there is no one area of research which is going to solve the world's problems. You know, energy, food, all of those things are going to be major challenges going forward. So I wouldn't worry too much about finding the one answer. I would come at it from the other end of the telescope and say, look at what your expertise is, and then have a look at which of those UN sustainability goals you think you can best apply it to, and that will help you direct your own area of specialism to the right place, rather than moving what you do into a different area.
Yeah, thank you a lot. Thank you.
Thank you, Alexei.
Thank you. Thank you for your very interesting presentation. I have one small question. You have presented 6 different models of interaction between researchers, government, and business. And if we take into account your own experience, maybe you will give for us some advice. Which model is more effectiveness, more efficient for us, for researchers?
I think the answer is that you need the reason there are so many models is because different models work better at different parts of the technology development journey. And it comes down to who is taking the risk and who is paying and who is benefiting. So, you know, more fundamental research, the industry doesn't even know whether it'll be relevant to them. So it's not realistic to ask industry to pay a lot of money towards that. So the mechanisms that you need there are typically going to be government funded, and you're going to decide where you put the funding by the quality of the science and the quality of the research. And then you'll worry about where the exploitation comes later. At the other end of the spectrum, if you're looking for taking technology that's already been developed and moving it through to industry, then mechanisms where industry, frankly, has some skin in the game, they put money in, they take some of the risk themselves, they are appropriate, because then it means that industry focuses properly. If they didn't have to pay any money towards it, there is a risk that they wouldn't take it seriously, and they would not then actually put the resources behind it that's needed. So I think the answer is you do need several different models that you can apply, and you use the right model in the right situation. So fundamental research is more heavily government funded or public funded, and applied research and exploitation should be more heavily industrially funded. The trick is to make sure that you've got an ability to recognize where your technology is and use the right mechanism at the right point in its gestation.
Okay, thank you so much for the answer.
Thank you, Jana.
Good evening. Thank you for your interesting presentation. I have some question. I'm really interested in how your experience in policy, technology, and industry collaboration could be applied in the natural sciences, like geology or ecology. Outcomes that are often hard to measure in money or products. Could you share some ideas how such collaborations helps turn the scientific research into real impact for the environmental and society?
Certainly. So one of the roles that I hold is I co-chair the Science and Technology Advisory Council for the UK Government Department for Energy Security and Net Zero. That's a lot of words, but basically it means that there is a group of scientists across lots of different fields who are available to give advice on request to the minister and to the department to help them to formulate policy in the area of energy security and provision of energy. And if you look across that group, It is a real mix of hard science and engineering at one end, through ecology and environment, and into psychology and human behavior at the other end. Because whenever a government minister needs to put policy in place, the science is one of the things that they need to consider, but it's actually only one of the things they need to consider. When a minister makes a policy, they are balancing social good with scientific excellence, with industrial or commercial profitability, with the ability to make this all work within a tax framework or a tax system. And all of those inputs are needed in equal measure. There is very rarely in policy a simple scientific answer. Normally, something that is that a politician will need to make a decision on is something which is a complex mix of social, economic, and science. So I would say there is a very strong role for ecology and for environment within that advice, because frankly, the public, the voting public who put our politicians in place, we care about those things, and we want to make sure that our politicians are taking them into account when they are setting policies.
Thank you so much.
So there were a few questions in the chat as well, but before I will read them, I want to ask myself, to be honest. So I would like to go back in ages before, like, or let's say when the founder was kind of when he founded the center. So what was he thinking? Because you mentioned that he looked at the automotive industry, but was it because he was interested, or because it was regional aspects of automotive being near Warwick? And then if you were to design this kind of collaboration from zero right now, so what would be your approach? Would you make some kind of, regional mapping? So how would you think about it?
So I would say we are a product of a very specific point in time. And what I mean by that is the University of Warwick is quite a young university in the UK. We were only founded in 1965. So in 1980, when Warwick Manufacturing Group was founded inside the university, the university was still quite young. And it was having to work out how it was going to compete on a global stage when you're in a country that also has Oxford and Cambridge and Imperial and many universities that have been around for hundreds of years and have very strong reputations. And that meant that the university was in a position where it was prepared to take some risks and do some different things to create a differentiated position for itself. And so when at that point in time, Lord Bhattacharya, who had a very strong interest in leadership and management of industry, and clearly being based in the Midlands, the industry he could see the best was the automotive sector. And the automotive sector was having a very difficult time. It was really struggling at that point. We had these three critical factors that all came together simultaneously, and that was a university that was willing to do something different and take some risks, a context where we definitely the industry needed some solutions to come forward, and a founder, Lord Bhattacharya, who was prepared to create a mechanism that sat within that in order to bring it together. And I think you do need those extraordinary points in time if you are going to create something which is radically different. Now, the good news is it's not radically different anymore. Now that we exist, and we're not the only people, so other organizations have followed and created similar models. It's now much easier to persuade a government or a university or a funder that a model like this could work, because there are case studies that you can demonstrate and show how it happens. What's difficult, because I have been asked by several universities if I would go and help them to create a WMG-like structure inside the university, is that particularly in the UK, the universities have grown up with a very fixed view of what a university should be and how it works. So normally, if I'm asked, I go and see the Vice-Chancellor, and I go and ask them a few questions. And the first question I ask is, are you prepared to have people drawn from industry working inside your organization, paid more than your academics, treated as peers to your professors, and helping to drive the research agenda? And normally they feel a bit uncomfortable about that because that's not how universities work. And then I ask them, and are you okay that the intellectual property that we develop, we're going to give that to those companies because they're going to run with it and they're going to exploit it in ways that the university simply isn't capable. And again, they start to squirm a little bit at that point because that really doesn't fit the standard model. And then I talk about the fact that you've got to be prepared to make space for and handle very large amounts of money to invest in the equipment that's needed to do these things. We manage something like £100 million worth of assets just inside my group. And to do that, you've got to be prepared to make some big financial decisions and some big financial risks. And again, for a lot of universities, that's a really risky thing to do. So right now, it would actually be quite hard for most universities to recreate what we have been lucky enough to run for years. And I think if we hadn't started at that magic point in time 45 years ago, it would have been very difficult to start afterwards. But I would say, those points in time exist. And those points in time particularly exist around big geopolitical upheavals. And one of the things that I really hope for Ukraine is when all of this is over and we're starting to look at rebuild and starting to look at economic growth and prosperity, those are the points in time when government tends to be open to listening to some of those new models and thinking about how they can do things differently in order to accelerate the economy and to accelerate growth. And if nothing else, that's one of my hopes for you.
Thank you. And that is why I'm asking you, this question, because I think the group here, I think they have this power to start thinking now, designing something, talking to industry, looking for partners, because I think there will be a point of time when, yes, there is a geographical shift, a geopolitical shift in the world, and Ukraine hopefully will prosper, right? So then it's kind of, you should be ready. You should have a plan, something. You should, already better to talk to people around, to the industry, to say, okay, we are ready. We have the group of people. We have some understanding of what are the needs in the region, to kind of say, okay, we're ready to change. And I mean, we have our challenges in terms of like the number of universities and like how it will change in the future and how to magnet the number of students also to studying in one university rather than another. So yeah, that is why I'm really curious. And then let's go to the question about the government.
Can I just pick up on that? Can I just pick up on that for one moment? Because if that is what you're looking to do, there are a couple of key things that you can do that make a big difference. The first is the more disruptive the thing that you're asking to do is relative to the system that you've got today, the greater the level of evidence that you need to present to government in order to take that step. And some of the evidence that you can look at would be international examples, and WMG is one, but there are half a dozen around the world that we could point you at that are slightly different models to achieve the same thing. The second thing is, if you can walk into government with industry standing by your side and saying, this is what we want, this is what we need, we as industry need to change, we know that we need this kind of input, then you're much more likely to succeed than if it appears to be a self-interested university or university system talking to government. So you really need to generate that connection with industry and help them understand what they can get from you if they were to create these large-scale kind of collaborative activities. And sorry, I interrupted your other question.
No, it's okay. I mean, I think this is another, kind of motivational or incentive for the participants to also to talk to the industry, to establish those partnerships, to have them by their backs once the time is right. So yeah, and my second question was about the engagement with the government and extension to which you need this collaboration. So also I want to go back in time to kind of early days of the center. So what were the crucial things back then? So was it really the governmental support, or rather than the collaboration between university and industry and then government kind of step into?
Yeah, to be honest, we started by helping industry. And the first step to creating the connection with government knew that we were working with industry, so they knew that we understood the real problems that industry had. Government also usually feels slightly suspicious if they're talking directly to industry, because industry always has a profit motive at the back. At the end of the day, they are there to serve their shareholders. They are there to generate profit. And so whenever government talks directly to industry, they're always asking themselves a question at the back of the head to say, is this conversation about doing the right thing for the country, or is this conversation about doing the right thing for the shareholders and generating profit? But once they understood that we were working very closely with industry, so we could truly understand the industrial context, government was much happier talking to us than they were talking directly to industry, because we are a charity, we are not a profit-making organization, we have no vested interest in a particular solution. At the same time, industry was really happy because they trusted us to put the right answers forward, the ones that actually made business sense for them. But we had to start with industry, build the trust and knowledge of industry. That was what then generated the conversation with government. But then obviously the government conversation then really energizes the conversation with industry, because then we can help translate what the government wants to see in its future policy into what the industry is likely to need to do in the future. But you have to start with industry and then bring government in alongside.
Sorry, I was muted. So I was saying that this is another incentive, to start talking to the industry rather than expecting the government to step in and do the first step. Okay, so let's go to if we have just a few questions in the chat. So the first one from Taras: what are the critical success factors that enables WMG to effectively combine academic activities with business needs?
Yeah. The first thing is we have to be brutally honest with people at the point of recruitment about what this is all about. There are some academics who really don't really want to get involved in industrialization. They would much rather focus on blue sky science and not worry about how their technology will ever make it to industry. And that's absolutely fine. That's how Nobel Prizes are won. It's not our mission. It is the mission for some universities. But what that means is that when we recruit academics into our organization, we're very honest with them about what we expect and what we want. And that means that some of them will naturally select out of the process. They will decide this is not the thing for them. And some of them will decide that this is the thing for them. But we do have to be really honest about it. You can't just take any academic and drop them into this environment and expect it will work. They have to be motivated to want to do that. And the same on the industrial side. The people that we bring in from industry have to be motivated to explore new ideas and not just do it the same way they always did. So we typically recruit people from the research and development functions in industry rather than from the product functions, because they typically have the right mindset to absorb those things. And then once you've done that, you haven't got that bigger gap to close anymore. You've got academic people who are interested in industry and industrial people who are interested in research, and closing that gap is much easier. And then it's all about the culture, and it's about making sure that you've got the same level of reward and recognition for the academics as the industrial people. You're not claiming everyone's the same. You're rewarding people for doing well, but what constitutes well is different for an academic than it is for industry, and both of them respect that you need the other's role in order for us to succeed. But there's a strong piece of cultural work needed to make that happen, and it doesn't come easily. It takes many years to develop that, and a lot of trust behind that as well.
Mm-hmm. Thank you. Then there is one more. I have a question related to health tech. How does WMG usually identify and support early stage healthcare projects for collaboration with industry, and what type of evidence of maturity level is most important at the initial stage?
Yeah. So in terms of picking which projects we work on, the first question we ask ourselves is, are we the right organization to help this company? Have we got the right skill set? Are we the best at this? Because if we're not, the first thing we'll do is signpost them to somewhere else. And if I was looking at health tech, I mean, you saw on the slide where I showed what technologies we are expert in. Some of the activities that we do, so things like development of batteries or data or AI, they're thoroughly relevant to health tech. And I would have no problem at all offering our services to a health tech company to help them on those. But what we are not expert in is the medical science or the role of the clinician. And so we would make sure that if the company needs that, we would reach out to a partner to make sure that that is there. The other thing that I would say is it is not necessarily our role to decide which companies will be successful and which companies will not. Our role is to make sure that the companies, when they come to us, get to success or failure as quickly and as efficiently as possible. So not all companies will succeed. And the worst thing for those that don't is they spend a long time and a lot of money working out that that's the case. So in our case, so we don't turn companies away based on whether we think they will work or succeed. What we do is we help them understand where are the risks in their business and really accelerate the progress towards understanding whether those risks can be overcome or not. So some of the companies we work with fail. And actually, that's a good outcome. If they fail efficiently without wasting time or money, that's a better outcome than failing in 5 years' time for the same reason. And some of those companies will go on to succeed, and we make sure that they succeed as quickly as possible, and that we de-risk the technology and the finance for the investors.
Perfect. And I think we have the last question here. So could you please explain how WMG supports collaboration with universities and industry at the early stages of innovation?
Yeah. So I would say at the early stages of innovation, when we're really looking at that early stage science, really the best you can do at that point is to be sounding out industry to understand whether this is even something of relevance to them. You know, if you look at real blue sky science where we're understanding the fundamental behavior of particles or matter or cosmology or something like that, it's essential knowledge. It will transform mankind in time, but it's probably not developed to the point that some industry companies could really understand where or why it might be relevant to them. So really the only way that I would suggest to engage at that really early stage, it is make sure you're engaging with the chief scientist or the chief technologist in the company, because they're probably the only person in the company capable of making that mental leap from where they are today to how your research might fit. And clearly the more research you can do to understand what the dynamics of that company or that industry sector are and where their pain points are, that might help you to make some suggestions on how your research might start to address their problems. And you don't need to go into it promising to solve them. You just need to be able to go into it and say, look, this is what I'm working on. I think it might be relevant to you. What do you think? Do you as a company think this might be relevant? Is it too early? You can ask questions along the lines of what would this need to look like for you to be able to engage with us? What level of proof would you need that this research works or could deliver a particular outcome? And they'll normally be quite clear with you about that. And it really helps you know what you need to do before you're going to be able to get that first successful engagement. But there are certain things that I would definitely avoid. If you're not going in there with a thought as don't expect the company to make the mental leap. If you go in there and just give an exposition on your research, they will feel that it's a waste of time and they will not be able to do anything with that information. And unfortunately, you only get one chance to make a first impression. So at that point, they will probably make a decision that they're not that interested in engaging with you. And unfortunately, 3 years later, when you are ready to engage with them, it's too late. You've already kind of set that expectation. So don't try and engage too early. Make sure that you're in a position you can make a credible business case to them on why they should be interested in what you're doing, or it's very unlikely to stick.
Perfect. Thank you so much. I think we had a great time and enjoyed your presentation a lot. Thank you for your time and for being present with us, answering all your questions. I think we'll have a right point of time, as you mentioned before, where all the aspects will go together. So we'll, be able to replicate your experience back in Ukraine. Thank you one more time. And I'll ask you the rest, because I'll need to address a few things about the participation and one-pager submission. So please feel free, because I will switch to Ukrainian most likely. Feel free to leave us if you want, or stay with us while I'll be matching a few more things.
I would love to speak Ukrainian, but I don't. So what I will say is, as I mentioned earlier, my contact details are on the slides, which are recorded. If anyone does have a question they wish they'd asked and didn't, then you're very welcome to contact me. And if I'm not the right person to answer it, then I'll put you in touch with people in our team. Otherwise, I'm hoping that we will see some of you when you come over for the visits, and I hope I get to meet with you. And I'll wish you well and say thank you very much. And I'll leave you at this point.
Yeah.
Thank you.
Thank you so much. Thank you, David. Thank you. Yeah, so I wanted just to double check with you guys on a few things. I will stop recording this.